the way that this unit has always been taught, and we continue to teach it this way, is get them to understand how to do tan really well. And if they understand tan really well, sine and cos just fall into place. See, you have to label your triangle, and then you have to pick the correct ratio. We've already learned how to label our triangles, and now picking the correct ratio shouldn't be a challenge for you if you are looking at the evidence in the question. So let's look at the sine ratio and the cos ratio. How are they different? Okay, so if this was the angle we were looking for, well, first of all, let's label our sides. Now, does anybody know, I'm not talking about opposite, adjacent, hypotenuse. What's the name for this side? Yes? Yeah, side BC or side lowercase a. Very good. Why? No. It's the opposite of angle A. Remember we learned that? So this would be A. This would be BA would be C, and then CA, B. Okay? So we still have to remember that, so that's a little bit of review. And how am I getting those? Because they're opposite their angles, and they're lowercase, right? Lowercase is the side, uppercase is the angle. Okay? Now from that, now this can get all confusing, right? Because we can label our sides depending on our angles. We could label our sides if we're doing Pythagoras, ABC, which they'd be different than this. And we label our sides compared to an angle, which is opposite, adjacent, hypotenuse. Okay? So a lot of things to keep straight. That's why it's good to have a study sheet, because it's hard to take a bunch of information and just organize it in your brain. But if you take it and you organize it in one place, then it's easily absorbed by the brain. That is the whole reason behind the study sheet. And that's why I don't want it on two sides. Okay? It's not that I don't care that you can use two sides, it's just then it goes against the purpose of keeping it all in one place and organized and seeing things right beside each other. Even if you turn things on opposite pages, you don't see the differences or similarities as well as if they're all on the same page. Now, if we were to label this triangle with our opposite, adjacent, hypotenuse, what would we call BA? That would be our adjacent, right? Or adjacent, okay? So I'll do ADJ so it doesn't get mixed up with our... How about CA? Hypotenuse. And how about BC? Opposite, right? It's the one I can draw an arrow to. So, the sine ratio, if you may not know, is, so sine theta equals opposite over hypotenuse. We're so used to saying opposite over adjacent, now we can't do that anymore. Now, according to this triangle, sine A would equal what over what? A over okay, everybody happy with that? I don't want fighting. Okay. So sine A would equal A over B. Now that could be just a simple multiple choice question on a test, right? Just to see, hey, like, do you know how to be able to maybe not just put it in your calculator, but also be able to just, because that's what the ratio equal. How about the cosine ratio? Remember that? Okay. So cos theta equals adjacent over hypotenuse. So this would be cos A equals C over B. Very good. That's all the new stuff for today. Okay? Nothing's new except for that, which isn't really that far of a stretch for us, right? Now, if we skip this, and get to that. Sorry, right here. Sorry, I didn't see you were still writing. Okay, so let's go 2 pages, or for you 1 page, I think. Okay. Okay, so let's find angle A here. And how about this one? We use the sine ratio. And this one, we use the cosine ratio. We've never used them before. Let's use them. Now, what do you notice about that first triangle? Do I have to use a sine ratio? What else could I use? I can use all of them, okay? So be careful about that because sometimes people get all confused. Like, which one should I use? Which one should I use? I can use whatever one you want, right? If I was writing a test, I would use sine the first time. Not sine all the time, but sine. And then maybe next time, because I'm going to do my test again, since I have time left over, I'll do cos on that one. If I get the same answer, I'm pretty confident I got it right, okay? So, if we're, first of all, before I guess we get too far, let's label our triangle, okay? This would be the, what's the 10? Adjacent and hypotenuse. So if we're using sine, I will go sine theta equals opposite over hypotenuse. Sine A equals opposite is 6 and hypotenuse is 13. See, if I had labeled my triangle, it's kind of a no-brainer. Okay, and I want everyone to try it. What do you get? 20, let's go 27.5 degrees. Now, if you were to do cosine on this one, let's try that. What if I did cosine on this one? Cosine would equal what over what? What did you say? No, I'm doing this one. 10 over 13. So try that out. Second cos, 10 over 13. What do you get? That shouldn't have been right. Try it again. Then this calculator must not exist. Or this triangle must not be a true triangle. I didn't try this way both ways last time. It should give us the identical, but I bet you this triangle cannot exist. Someone just picked random numbers. You must not be wrong. Like the triangle must be. Okay. So for this, because this triangle, if you were trying to build it, I bet you wouldn't be able to work. A 10 by 6 by 13. Because if this was a real triangle, I know you're thinking, well, it is a real triangle. It looks like a triangle. 13 wouldn't be long enough. This is real. I mean, we could even check it out, right? 10 squared plus 6 squared. Take the square root of that. What should that side be? 11.7? Is that what we get? So that should have been 11.7 for this to have worked. Okay? So your triangles on a test would have to work. Right? You couldn't do that to students and just make up. Okay. So let's do cos A on this one. Now, we want to label all of our angles. All of our sides, I should say. So the 25 would be the opposite. 16 and so cos theta equals adjacent over hypotenuse. Cos theta, oh no, cos A equals 16 centimeters over 30 centimeters. Okay, and again, make sure we're using second cos so we're able to so A equals 57.8 degrees. Okay. Does that make sense? Okay, let's go to here. Okay, now on the grid paper, illustrate and label these triangles. Now just by given sine A equals 3 over 5, can we draw a triangle?
Yes.
Okay, what's the 3? And the 5? Okay, so my question would be, how do we draw? Okay, so here's one side. 1, 2, 3. That's the opposite, right? How do you draw 5 as a hypotenuse? No, no, that's not slope. We have to find the adjacent, don't we? So since we know two sides of a triangle, what sides do we know of this triangle?
A squared and C squared.
Yeah, we know opposite, which is 3, and we know the 5. How are we going to find the adjacent? Yep.
C squared minus.
So 5 squared minus 3 squared, and if we take the square root of that, let's see if we can do this in our head. What's 5 squared? Minus 9. Square root of 16. Boom. Who needs a calculator? So if this was 3, then this would have been 1, 2, 3, 4. Okay, so if that was 3, this is 4. Then you could see this would be 5. Okay, that's what you're trying. So that would actually be the accurate triangle. See, with opposite and adjacent with 10, it was easy. They gave us the x and the y. But now when they give us the hypotenuse, we got to go figure it out. Okay. This one stung a little bit for the other class. We'll see how this one goes. Draw me a triangle for sine 56. Okay? Okay? Give me some suggestions to start this one. Oh yeah, by the way, we should have said this is angle A here. Come on, any strategies? Okay, so maybe if we just drew just a triangle to kind of get our bearings, we know there's a 90, right? We know that this is 56 degrees. Has to be what? Okay, that's true. But that does not help me get any sides. So finding another angle, it's all good, but it's not going to help us get sides any better. Yeah, well, hey, the other class got that too. Now, I'm not letting you guys off the hook. Let's figure it out. What would we do? Okay. So this would be the opposite, right? That's adjacent. That's hypotenuse. Is there anything we can calculate? Yeah. Yeah, we did that already, right? Yeah. Not helping us with the sides, though. Yeah? Yes, what would you do? Math, enter after you get it. probably not given one to use it. Okay. So this is why this is a good question. Like, you're getting close. You guys have no idea how close you are. Yeah?
If you have, so sine 56 equals 0.82, so that in a fraction.
Okay. Let's do it a little better than that. It was 0.829. This is what it equals, correct? Does it equal, does this equal this? Yeah. Doesn't 3 equal 3 over 1? 20 equal 20 over 1? But what was the point of doing that? Now I have opposite hypotenuse. Now, but, like, come on, like, how am I supposed to graph 0.8 on my graph and a 1? So you move your decimal over 1 here, move it over 1 here. So 8.29 over 10. Okay, so now I know my opposite is 8.29. I know my hypotenuse is 10. Can I find my adjacent? So you go 10 squared minus 8.29 squared. What do you get? Square root it. Because I moved the decimal, because 0.8 is hard to put on a graph. So I moved the decimal on each one of them. Now it's 8. Because there's about 10 billion triangles, because I could do 82.9 over 100. See, all of those triangles would give the same angle. Yes. But you got to make it fit on your grid. Right? So you'd have to label it correctly. What did we get? 5.6. Okay, now I can draw it, right? Like if I started here and I went 1, 2, 3, 4, 5. 5.6, so don't quite go all the way, and then up to 8.29. Okay, and then I could draw my 10 hypotenuse. Okay, so that's what that triangle would look like. And if you had a protractor, you could put it down and you would honestly get around 56 degrees. I know it's hard to do 8.29, but it's a very good estimate. Yes? All you go is sine 56 equals. Put in a calculator, sine 56. Just like it says, sine 56 equals. Well, yours is different, right? Yeah, you need to get a good calculator, you guys. Okay. So, here's a question for you. Why can you not find sine A equals 5 over 3? Try it. Second function sine, 5 over 3. Just try it. Find the angle. Opposite, right? Do you see how this is supposed to be opposite over hypotenuse? Is the opposite ever allowed to be bigger than hypotenuse, right? So this triangle does not exist. But I will get students that mix those up and they'll come up and they're like, Mr. Trump, I'm getting error. I'm getting error in my calculator. I'm going, well, look, you got like 5 over 3. That's impossible. And they're like, why is it impossible? And I go, well, what's the formula mean? It's opposite over hypotenuse. Your opposite's bigger than hypotenuse. What was the definition of hypotenuse? Got to be the long side of a triangle, right? So your hypotenuse always has to be bigger than the adjacent or the opposite. Okay? So this is your assignment. I want you to go like this too. Cross it out. Yes. And then turn to the next page. So you get it? Caught picking his nose. He's in the carrot section. And he's a snowman. He's picking a nose. Okay, but that's not the good one. Look at this one. Kid's like, Dad, it's so cold in here. And he goes, we'll go stand in the corner. And he goes, why? Because the corner's 90 degrees. See? Okay. Now, let's talk about two definitions here. We have direct measurement and indirect measurement. What? Really? Nice. Because the other class is like, oh, this is all new for them. So they're going to science going, oh, man, we do this and that. Okay, so somebody tell me what direct measurement is.
Oh, what number? When it changes, it affects another number to go up.
No, we're talking different things. Yeah. This is a pretty simple concept. A direct measurement is when you use a measuring tool to measure something. Okay? So when you're measuring a desk and you get out your tape measure, that is direct measurement. One thing that you'll find, maybe you'll be going, hey, yeah, that's me too, but whenever students are given these like measurements, they're like, oh, wow, that's a lot. But do you ever think, how'd they get that? Like they know the height of Mount Everest. They know like the deepest part of the ocean. Yeah, exactly. You think they took a tape measure? But do you think kids ever go, how'd they do that? No, they're like, yeah, it's pretty high. Well, it's cold up there, so yeah, I believe it. You know, they're just like, but an indirect measurement is when we use mathematical reasoning and what does that mean? Formulas, ratios, to calculate a length or angle. Okay? And it can be, and it is extremely accurate. When you've seen surveyors on the side of the road, the yellow things, and they're looking through stuff, and you're driving by, that's all they're doing. Okay? They're getting their measurements that way. They're not walking along with it like a measuring tape from like one corner to the other. Right? And that's actually a lot less accurate. I mean, think about if you, okay, who's taking up the tape measure to Mount Everest? Okay, me. Okay, a couple days later, it stops moving at the bottom. You're like, ah, crap. Goodness, send another guy up. We lost him too, right? So, next. Who didn't do their homework? Okay, you're going, John. Now, if we had a mountain, right? Just think, and there you are, very little. No, you're not even, this is like, you know, if you're like off by like a foot on Mount Everest, no one's going to fault you on it. Like, that's lame. I thought it was like a foot higher than that. Okay, no one does that, right? So what they do is they take the measurement from on the ground, okay? And they can actually do that just by direct laser too. And what they do is they take a measurement and they can hit the top of the mountain. So they can get this and they can get this. And you can see how they can calculate the height now. All they have to do is take a laser and they can shoot it up there and it'll give an exact measurement. You can just, as long as you see the peak. No, you don't see the laser. Like I've got a laser tape measure. I can just go like that. It'll tell me exact distance from me to the wall. And you know how they get you in laser when you're driving? It's just doesn't have to come back. It's just able to. It knows when the beam stops. Okay, because that's how they get you driving too. It's laser. It's bang, right? And then you know how the speed you have. Radar used to have to bounce and come back, and then they could tell you how fast it's going. So they have measurements good enough to do that, and this angle is important for them. They can get that angle because all they do is they put it at that angle, and they can see the total top of it, and they get the angle. Okay? So if you know the angle, and you know two sides, you can get your third side. Okay? So, you know, like the Sine tower and all those things, no one's ever dropped a tape measure down. This is how they've done it. Okay? Using trig. At the last school I taught at, we had this really big building beside us, and because of I was able to get it from someone, and they had the exact height of the building. And I would get my students, we would build like these clinometers, and we would just do it. And like every student could get close. And some students, and then we had a contest who could get, because I knew the exact measurement, who could get right on, right? And sometimes they get within, you know, 10, 15 centimeters. If you're talking the height of a building, 10, 15 centimeters, it's pretty good. And this is with paper clinometers and string and stuff, right? Surveyors, they're on perfect, right? So that's indirect measurement. No one actually climbs to the top and drops a tape measure, okay? They just use. So that's all surveyors really do. That's their job. Okay, let's. We're going to do 2 of these, and then you're good to go. Okay, so for this one, let's do this one for you is A. We're going to do A and D. Okay. So first of all, let's label our triangle. The A would be what? Adjacent. The 12 would be hypotenuse. And the side that we don't care about, opposite. Okay? So it's important to say it that way because I really need you to know it has nothing to do with this question. Right? So which of the ratios would I pick? Cos. Cos, right? Because it's ca. Now remember, cos is COS to spell it. So don't think it's opposite over symposium or whatever you would pick to put that there. Okay? So it's ca cos theta equals adjacent over hypotenuse. And now you can kind of see why that is worth a mark because honestly, if you're getting this, I'm like, okay, that's good, they're learning it. Because the other stuff we've done over and over and over again, nothing is new. So we do our substitution, cos 23 degrees equals, and all we do is match, right? So we've got adjacent, which is A, over hypotenuse, which is 12 centimeters. No, you say that every time. That's twice. No, you said, didn't you say elevator? No. No. He's just guilty by approximation. So, take the escalator, not the elevator. Okay. So you take the escalator. Have you ever been stuck in an elevator? Have you ever been stuck on an escalator? Exactly. So take the escalator. Send someone.
Has someone actually called the person on the escalator?
That's a Far Side cartoon. It's in there somewhere. Well, then those people should move. Okay? So 12 times cos 23. Let's move so we can get to the nearest. Does it say? Nope. So let's go 11.0 centimeters. Because it shows I round to the nearest tenth. No, it tells me my next number is definitely 4 or lower. Okay. Why are we talking? Yes. That's another story. Okay. And besides, I'm taping right now, so we won't talk about D. Okay. So label your triangle quickly. Question D we're doing now. So opposite and hypotenuse are what we're dealing with, right? So that's so. So sine theta equals, now I know you just want to get right into it, right? Put stuff in, but that's where students do make problems because they put the wrong formula down. They'll put sine equals adjacent over hypotenuse. And I want them to always say the acronym after they're done. Okay, so, okay, good. Right? Double check, you guys, because that's what's going to, you're going to make the mistake there if you make it anywhere. You're actually going to write it down incorrectly. So write it down so you're like, okay, so, and then we fill in sine 56 equals, opposite is 13 kilometers over x. Okay, now what happens in this one? They trade. So x equals 13 kilometers over sine 56 degrees. To one decimal place? 7 units. Okay. So, the only thing new, picking the right ratio. Now, you see where it says cut out clinometers? You see that on the bottom of your page? Just go like this. It's just like a protractor that measures angles. Okay, so let's get working on this. If we're working hard and using our time well, then the last 10 minutes we can get our tests back. But I want it quiet and people working so they can get this. I've taken off half the homework, right? I took that other assignment off. So you're just working on this one. Because if you know how to do this assignment, it would cover the last one.